so moving on, daily lessons, page 135. So in this one, a particle moves along the x-axis so that its velocity at time t is given by this formula. So v of t, this function, v of t is equal to negative quantity t plus 1 times sine of t squared over 2. Okay, so in this one, it's asking you to find the acceleration. And again, this is old school. It's 2003 now, so 1 year later than the last problem. But still, they really are concerned about procedures, not so much units, anything else. Lucky for you, that's all changed, so you have to do units. Okay, find the acceleration of the particle at t equals 2. Acceleration is not what's given. Velocity is given. So you need to remember, what is the relationship? Position, velocity, acceleration. So the derivative of position is velocity, the derivative of velocity is acceleration. So in this one, I want the derivative of velocity at 2, which is the same thing as the acceleration of the particle at 2. So in order to do that, I need to figure out what is the derivative. So d prime of t. This one, I've got a product rule. Yeah, and chain rule. Wow. Okay, so I'm going to do the first times the derivative of the second. The derivative of sine is cosine. What do I do to the inside? That's right, I leave it alone. Times the derivative of the inside. Okay, so this one, if you think about this, t squared over 2, I could do the quotient rule, but nobody wants to do that. Think about that as 1/2 t squared. So what I'm doing is I'm taking the derivative. I would say 2 times 1/2 is just 1 t. Take the exponent down by 1, so it's just t. Remember product rule though, so we're not done yet. So first times the derivative of the second plus the second, so sine t squared over 2 times the derivative of the first. Okay, so the derivative of the first, I could take this through and I could call this negative t minus 1. So I know the derivative of negative t minus 1, that whole quantity, would just be negative 1. Okay, so it's saying find the acceleration at 2. So what I need to do is I plug in 2 to all these places. So you can stop me, you can go ahead and do that now. Or you can trust that everywhere I put in 2, and I got 1.587. Okay, so I answered this part. Find the acceleration, I did that. The next thing, is the speed of the particle increasing at t equals 2? So, in order for speed to be increasing, you should be thinking about acceleration and velocity. If they have the same signs, the speed is increasing. If they have different signs, the speed is decreasing. In this case, speed of the particle increasing at time t equals 2. So what I want to do is, I want to say, I already know velocity, the derivative of velocity, the acceleration at time t equals 2. So I just need to know the velocity at time t equals 2. So I'm going to take t equals 2, and I'm going to put that in here. Sine 2 squared would be 4 over 2. And this would definitely be a calculator problem because you're not going to know the sine of 2 in your head, or at least I don't. If you do, you should do something else with your time too, or be amazing, I mean. Okay, so v of 2, in this one, you would get negative 2.727. I'm sure you totally did that on your own, didn't just wait for me to give you the answer. I can see a of 2 is positive, v of 2 is negative. As a of 2 and v of 2, or I can even say as a of 2 is greater than 0 and v of 2 is less than 0, speed of the particle is decreasing. Not increasing, it's decreasing, and I should say at t equals 2. Okay, next one. Find all the times where the particle changes directions. So So think about this. If you're talking about a particle changing directions, the only thing I care about is velocity, positive or negative. Because if velocity is positive, you're moving to the right. If velocity is negative, you're moving to the left. So I want to know, and the places where it would change would be where the velocity is 0. To go from negative to positive or positive to negative, you need to have a, some crossover between negative and positive, positive and negative. It would be 0 somewhere. So what I'm going to do is I'm going to set velocity equal to 0. So I'm going to go up here, and I've got negative t plus 1 sine t squared over 2. And I set this equal to 0. And so what you can do here is you could do some of this by hand, but it would take a whole lot of work. And I already told you that this one would definitely be calculator. And question number 2, actually 1 through 3 in most cases was calculator up until 7 years ago. I forget what it is. Maybe it wasn't even then. Maybe it's just 1 and 2 and now you get what, I don't know. I'll have to check on that for you. But either way, this calculator would have been calculator. So I would say, put this into your equation into y1. See where it equals 0. Just make sure that you're on the interval from 0 to 3. When I did that, I found that v of 2.506, so when t equaled 2.506, that's when the particle changes direction. Well, I don't know that. Well, that's when the particle is equal to, or the particle's velocity. Be really careful about language. You can tell it's sometimes easy to get caught up in this. That's when the particle's velocity is going to be equal to 0. It may or may not change directions. It could be the particle's moving along, stops, and then continues to move along. So you have to make sure, just like to find a min or a max, you need to make sure that it's changing from positive to negative or negative to positive. Same deal here. You have to make sure there's not just a horizontal tangent on the position graph. Okay, t equals 5.06. The way that we do this, we make a chart. So this is t, this is v of t. I'm going to go from 0 to 2.506. Stop at 2.506, where I know the velocity is 0. Go from 2.506 to 3. And I pick a value. Between 0 and 2.506, I would pick 1 probably. And I go back up to here, and I put it in. I substitute t is equal to 1. If I do that, I find out that this value is going to be negative. I'm going to do the same thing over here, 2.506 to 3. I'm going to pick something. You can pick 2.7, you can pick 2.9. It doesn't matter. You can just use your calculator. This is where it would be helpful if you would have stored 2.9 in for x and then write all of this into the into just like the main screen, or you could go into your graph and find the function value at 2.9. But if you do that, you find that this is positive. Yay! Okay, so we're at 2.506. It's not, the velocity is not only 0, but it goes from negative to positive, which means that the particle is changing directions. The particle was moving left, now it's moving right. This is a really exciting particle. So, in this one you would say, make sure you're answering the question, when is the particle changing directions? I would say, the particle is changing directions at t equals 2.506. And I need to give a justification. Even though I have a chart, I need the chart's not enough. So I need to say as v of t changes from negative to positive. And if we really want to be specific, we can say the particle changes from moving left to right. Okay, we did it. Daily lesson page 135 is done.